Hey guys, I hope you all are doing well. Today's lesson, what we're going to go ahead and do is we're going to take a look at finding the vertex and intercepts of a quadratic equation. But this time we're going to be looking at it in standard form. Okay, now our quadratic equation in standard form looks like the following: y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. This has to be specific because if a is equal to 0, then it won't be a quadratic. It will be a linear equation, and that's not what we're dealing with at the moment, right? So the only condition is that a cannot equal to 0. But a can be anything. It can be 2.5, it can be -5, as long as it's a real number, okay? And based off of this equation here, I can find some of the properties based off of this given equation, right? So, for example, I can determine whether A opens up or opens down, right? So, just by looking at this and finding this value of A right here, so that's what we're going to go ahead and take a look at, right? If A is greater than 0, then the following is true. Then the quadratic the quadratic opens upward, right? Upward. Um, it opens upward, and we have a minimum. And we have a minimum. And so what this would look like, it would look like this. If I'm just going to draw a little sketch, right? This is my axes, and it'll look something like that. Now that's a terrible sketch, and that's okay, right? I'm not looking at anything specific at this moment, okay? Another thing, if a is less than 0, meaning that a is a negative number, then it opens downwards. It opens downwards, and we have a max. We have a maximum. We have a maximum at the vertex. So if I were to draw a set of axes, it'll look something like this. It'll look something like this, and that will be our max right there, right? That would be our maximum. Um, like I said, I know there's a lot of writing, but um, if you feel like I'm going too fast, you have the liberty to pause whenever you want, right? So if you want to pause it first and then kind of come back and listen, you can work at your own pace. Now, this is a sketch, right? I'm not focusing on graphing at the moment. What I do want to know are some of the key features. Also, from this here, right, from this standard equation, one thing I can go ahead and figure out is the following. I can find the axis of symmetry along with the x-coordinate of the vertex. Okay, now I can take this equation right here, this equation of the standard quadratic, or excuse me, this equation of this quadratic equation in standard form, and I can complete the square to find the following, to find the x-coordinate of my vertex. And that, in this case here, the axis of symmetry along with the x-coordinate of my vertex is going to be the following. X is equal to the opposite of b over 2a. Now I can go ahead and show you this by completing the square. But for the sake of time, we can just go ahead and use this here for both my axis of symmetry and my x-coordinate of my vertex. Now, in the previous video, we were taking a look at some of these quadratics that had roots, that had x values, right? We're looking at quadratics in factored form. But quadratics don't necessarily always have to intercept the x-axis. And so that's what I want to go ahead and help you figure out here is like, how can we find this axis of symmetry when I don't know the roots, when we don't know the roots? Now, we found all these key features, but it doesn't necessarily matter which order we go in first. You don't have to do my order. Like, let's say, for example, hey, I found that finding the x-intercepts first work well, then I can find everything else. Whatever works for you. You don't have to do it in the same order that I do it. You can do it whichever way you feel more comfortable. Okay, let's go ahead. Let's dive into this first problem. Okay, I'm going to go ahead and leave that right there so it's a little visible. Okay, we're going to go ahead and do the following. Is I'm going to find the following for this given quadratic equation. I have y equals x squared minus 4x minus 7. Um, so I want to find the vertex, the axis of symmetry, and all the intercepts, right? X, Y intercepts. Now it's up to you which order you go first. If you want to find, what I'm going to start off with is I'm going to start off by finding the axis of symmetry. Okay, and my work's going to be all over the place. I'm not focusing on graphing at this for this specific one, but I will draw a sketch of what it would look like. Okay, so let's go ahead and let's find the axis of symmetry. Okay, so the axis of symmetry, x is equal to the opposite of b over 2a. And in this case here, a is equal to 1, b is equal to -4, and c is equal to -7. I only need these two values here. Okay, so wherever there's a variable, I'm going to go ahead and I'm going to put parentheses. Okay, so that's going to be a -4 all over 2 times a is 1. Okay, this right here is going to be equal to -4, um, the opposite of -4 over 2, right? 2 times 1 is 2. And we will see that this right here will end up being +2, right? +2. Now, if I take this exact value here and enter it into my calculator, look, I'm using this a over b. Up here is going to be my -4. Anywhere I have a variable, I'm putting up parentheses. And you can do that as well. All over, let me erase that. 2 times 1. Close that up. Look at that, 2. So you can use your calculator as well. Anywhere you see a variable, go ahead and put parentheses, right? The signs are important. So keep that in mind. Okay, so let's go ahead. I found my axis of symmetry. Axis of symmetry, I'm going to abbreviate. Symmetry is x equals 2. Okay, we'll come back to this in a bit and I'll draw a sketch of what this looks like. Okay, so I have my axis of symmetry. I got that out of the way right there. Okay, now since this is my also my x coordinate of my vertex, okay, my vertex, I'm going to go ahead and use my given equation. Anywhere I have an x, I'm going to put a parentheses there. Okay, and since this is my x coordinate of my vertex, I'm going to substitute in this 2 into all of these right over here. And just like I did in the previous one, right, I'm going to go ahead and wherever I have a variable, I'm going to put a parentheses, -4 times something, and -7. Okay, and in here is going to be the x coordinate of my vertex, which is 2. Put a 2 in there and a 2 in here, and we get that our vertex is at 2, this right here, y equals -11. Okay, -11. So let's go ahead, and my vertex right here is going to be 2, -11. Okay, 2, -11. So look, I have everything. I have my, not everything, I have my vertex. All I need are my x and y intercepts. Okay. Now, if you don't recall from one of the previous assignments where we worked with the discriminant, right? Where we worked with the discriminant, where we had to figure out whether these are factorable or not. If I find the discriminant of this one here, you would see that it is not a perfect square. So what you have to do is you have to well, we know that it's not factorable, okay? And so we're going to have to use a quadratic formula to solve for these roots. So let's go ahead. Before I do that, I'm going to find the y-intercept. Okay, so my y-intercept, I have my y-intercept. I have it's the value of x when y equals 0. So y is equal to 0 squared minus 4 times 0 minus 7. So y is equal to, let's find that out. Instead of this one right here, what you can do is you can copy and paste it, but I'm not going to go ahead and do that. Close that, square minus 4 times 0 minus 7, and we see that our y-intercept is 0, negative 7. And since this is not factorable, we use our quadratic formula. Y is equal to, or x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac, okay, all over 2a. And my values are right up here, okay. Once you simplify all this, you would get that x is equal to 4 plus or minus the square root of 44 all over 2, okay. And we would get that x is equal to 4 plus the square root of 44 over 2, or x is equal to 4 minus the square root of 44 all over 2, okay? And we get approximate values that this here is 5.3, and this right here is, or x is equal to, negative 1.3. So my x and y intercepts, right? X-intercepts, we get negative 1.30 and 5.30. Okay, so these are my x-intercepts. So we have all of the three, right? We have our vertex, our axis of symmetry, and our x-intercepts right over here. All right, here we have another one. We have to find the following for the given quadratic, vertex, axis of symmetry, and all the intercepts. Okay, so here we have y equals x squared minus 2x plus 2. All right, so I'm going to go ahead and start with the axis of symmetry. All right, axis of symmetry. I'm going to run through this one pretty fast. So if you have any questions, feel free to email me. Let me know. Like, hey, I don't know how you did this part right here in the second problem. Okay, so please let me know. All right, so let's go ahead. Let's take a look at this right here is going to be negative b over 2a, or the opposite of b over 2a. In this case here, a is equal to 1, b is equal to negative 2, and c is equal to 2. Okay, so let's go ahead, just like we did in the previous one. X is equal to the opposite of negative 2 all over 2 times 1. And if you enter this into your handy dandy calculator, you'll see that this right here is equal to, I'm going to do one more step, negative 2 over 2. This right here will be equal to positive 1. Okay, that will equal to positive 1. Next, we're going to go ahead and find our vertex right here. X is equal to 1. My axis of symmetry right there. Bam. So, I found one of my things, my vertex. Okay, my vertex, this right here, is going to be equal to, well, I know my x coordinate, right? It's 1 from my axis of symmetry. And so I'm going to use my equation, y is equal to something squared minus 2 times something plus 2. And in these parentheses goes everything, or excuse me, x for every parenthesis, my x value for every parentheses, right? Once I simplify this here, we'd get that y is equal to 1. So I have a vertex at 1, 1. Okay? Next, what I want to go ahead and do is I want to find my y-intercept. Okay, so for my y-intercept, what I'm going to go ahead and do is I'm going to go ahead and let x equals 0. And you can do this for any quadratic and it will work. So that way you can find your y-intercepts. In this situation here, y is equal to 0 squared minus 2 times 0 plus 2. Okay, once I simplify all of that, y is equal to 2. So my y-intercept is going to be 0 comma 2. Okay, my y-intercept 0 comma 2. Now if I were to try and find my x-intercepts, right, my x-intercepts for quadratics, if we have x-intercepts, we have 2. Okay, But if you were to use a quadratic formula, right? If I were to do x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, right? Once I simplify all of this here, I can go ahead and I will see that I will get 2 plus or minus the square root of negative 4 all over 2. Now we know what kind of solutions we have when we have this a negative as our discriminant, right? We know that we have two complex solutions. So in this situation here, there are no intercepts. And if I were to draw a sketch of this here, right? And like I said, this is just a sketch. If I were to draw a sketch using this information that I found here, right? Let's say, for example, my vertex is 1, 1. So let's go ahead. That's 1, 1 right there. And my y-intercept is at 0, 2, 0, 2 right there. And since my axis of symmetry is right in there, that means that I have another point directly 1 unit away, right over here. And if I were to draw the sketch, notice that I have these 3 key points and I have no x-intercepts. So in this situation here, we have no x-intercepts, and that's what we're trying to find in the following.